All right, welcome. Got an exam on proteins coming up? Perfect. We're going to break down everything you absolutely need to know, from their basic building blocks all the way to some truly bizarre examples of when they go wrong.
So, here's the plan. First up, what even are proteins? Then we'll get into why your diet matters so much and how we actually rate different protein sources. After that, we'll get practical and figure out your daily protein number before we finish with a couple of fascinating and kind of creepy cautionary tales. Okay, first things first, what are proteins? I mean, we hear that word all the time, right? But what are they really? Let's get to the heart of why they are so critical for literally everything your body does. Well, you probably guessed it. They're all made of proteins. The best way to think about them is like they're the tiny little machines inside our bodies, the microscopic workers doing all the critical jobs that keep you alive and kicking. Okay, so it all starts at the smallest level with something called a monomer. For proteins, that monomer is an amino acid. And honestly, the Lego brick analogy, it's perfect. Your body has this giant box of Legos with 20 different kinds of bricks inside. So you take those bricks, the amino acids, and you start clicking them together in a very, very specific order. When you do that, you build a polymer. And that finished polymer, that's your protein. It's the complete model built using the exact instructions found in your DNA. And just look at this list. It really drives home how important they are. Proteins aren't just for building muscles. Nope. They're your hormones, like insulin. They're the collagen that holds your skin together. They're the antibodies fighting off germs. They are literally doing all the heavy lifting in your body. Now, this is maybe the most important thing to remember for your exam. For a protein, shape is everything. It has to be folded into this perfect, precise 3D structure to do its job. If that fold is even a little bit off, well, at best, it's useless. At worst, it can cause some really devastating diseases like sickle cell or Alzheimer's. Okay, so that raises a good question, right? If our bodies are so good at building these protein machines, why do we have to bother eating them? Let's dig into how this all connects to what's on your plate. And here's the answer. And this is a big one to remember. Our bodies can actually whip up some amino acids on their own. We call those non-essential. But, and this is the important part, there's a whole group of them, the essential ones, that our bodies just can't make. No way, no how. The only way we can get them is from the food we eat. That's it. That's why protein is a non-negotiable part of our diet. All right, so if we have to eat them, you're probably wondering, are all protein sources created equal? Like, is a steak the same as a handful of peanuts? How can we tell what's good? Well, scientists have a system for this, and it's got a bit of a mouthful of a name. PDCAS. Yeah, I know. It stands for Protein Digestibility Corrected Amino Acid Score. All you really need to know is that it's basically a quality score. It answers two simple questions. Does it have the amino acids we need? And can our bodies actually break it down and use it? So if we look at some of the scores, you can see how this plays out. The perfect score is a 1.0. And you see things like milk, eggs, and soy protein hitting that perfect score. They've got all the essential amino acids our bodies need. But then you look further down the list at things like peanuts or wheat, and you see the scores drop. That just means they're missing or low in one or more of those essential Lego bricks. But hold on, this doesn't mean you should stop eating bread or peanuts. There's a really simple fix for this. It's called complementary proteins. It's basically just food pairing. For example, pasta is low in one specific amino acid, lysine. But guess what's packed with lysine? Cheese. So you put them together, mac and cheese anyone? And boom, you've got a complete protein meal. It's that easy. Okay, this brings us to a super practical question, and one you might even see on a test. How much protein do you actually need to eat every day? The general guideline from the USDA is that somewhere between 10 and 35% of your total daily calories should come from protein. Now, I know what you're thinking. That's a pretty huge range, right? So let's break down how you turn that percentage into a real number. Let's use this example. Jose, let's say he needs about 2,800 calories a day. Okay, first step, we find the low end of the range. 10% of 2,800 is 280 calories. Easy. Step 2, find the high end. 35% is 980 calories. Now for the most important step, and don't forget this part. You have to convert those calories into grams. Protein has 4 calories per gram, so we just divide by 4. That gives Jose a daily target of somewhere between 70 and 245 grams of protein. And trying to stay inside that range is a pretty big deal. Getting this number wrong has real consequences. If you consistently eat way too much protein, it's been linked to problems like kidney stones. But on the flip side, getting too little can lead to a really severe deficiency disease called kwashiorkor, which you can see causes muscle wasting and that characteristic swelling. All right, to wrap things up, we're going to look at what happens when the whole protein system goes completely off the rails. These are two pretty extreme, but trust me, very memorable stories.
First up, we have something called a prion. Now, a prion isn't a virus, it's not bacteria, it's a protein, but it's a misfolded protein that acts like a zombie. It bumps into a healthy, normal protein and forces it to misfold too. And now you have two zombies, and they go find more, setting off this terrifying chain reaction in the brain.
This zombie-like chain reaction is what causes these diseases. They're incredibly rare, thank goodness, but they're always fatal. You've probably heard of mad cow disease, which comes from infected cattle. And there's a really famous historical case called Kuru, which was found in the Fore people of New Guinea and was linked to cannibalism. Okay, so from a fatal brain disease, let's pivot to something totally different, a modern health trend. You may have heard of this, placentophagy. It's the practice of consuming the placenta after childbirth, usually dried and put into capsules. Now, even though this has become kind of popular in some circles, the science on it is really, really clear. There is zero scientific evidence of any health benefits, period. But what we do have is evidence of risk. There are documented cases of serious bacterial infections being passed to the baby this way, not to mention the potential for consuming unsafe levels of hormones. So, what's the big takeaway here? Proteins are, without a doubt, the fundamental building blocks of life. They build us, they run us, they protect us. But that foundation can be surprisingly fragile. And when it gets flawed, whether it's from our diet, our genes, or some rogue zombie protein, the consequences can be absolutely profound.